Today's AI models based on LLMs are brilliant. However, they cannot accomplish much on their own. They need access to external tools like databases or browsers in order to do something that's truly meaningful. This is where Model Context Protocol comes in. It promises to connect any LLM to any tool. But does it live up to that promise? What is so unique about it that existing protocols like REST cannot offer? Let's find out. Welcome to AI Club Pro, where we make AI concepts feel like everyday ideas. MCP, short for Model Context Protocol, is a layer that helps LLMs interact with different tools. Anthropic came up with it, but it was so compelling that others like DeepMind, Microsoft, OpenAI jumped on board within months. In this video, we'll go over how things would have to work in the absence of MCP. Why something existing like REST API could not be used for this task, and how MCP works and places that it cracks. Much before MCP arrived, connecting large language models to real-world stuff was 90% glue code. This becomes easy to explain using an example. Say I want to build an AI assistant that summarizes active incidents in our production environment. I wire 4 adapters in my code. One to pull CloudWatch alarms, what's red, which service it maps to, etc. One for querying a metric in Datadog, just to sanity check the signal. One to open a Jira ticket if it's real, and another to post the summary on Slack. All this works until something tiny changes. And then Monday morning is spent fixing the glue code rather than fixing the bugs. So that's the pre-MCP world. I handwire adapters, and if another team builds the same thing, they need to write this code all over again. Or you could lean on things like LangChain, which would orchestrate this code for you. MCP flips this around. Tools like Jira, Slack, etc. are exposed once via standard server, and any compliant agent can discover and use them. A natural question is, how does the interaction with these servers look? And who makes these servers available? First thing to note is that there is a concept of MCP server and a MCP client. MCP server is responsible for exposing capabilities of the source you're connecting to. This could be tools, prompts, or resources. The server is responsible for validating inputs, executing work, and returning structured results over a transport. This transport could be STDIO or streamable HTTP. This server is always listening for requests on a port, just like a REST API. An MCP client, on the other hand, exists in your application or agent runtime. This client could be an editor extension or a backend service. It has the ability to discover servers, list their tools, call them with typed arguments, stream outputs or events, enforce authentication, timeouts, retries, and orchestrate multi-step workflows across multiple servers. This might sound abstract, so we'll clarify this with some examples. The first thing to note is typically you are responsible for spinning up your server. It is important to note that many vendors now host remote MCP servers to which you can connect directly. We'll go into those details shortly. So wait, if you're launching the server, isn't it like moving some of the glue code or the logic into a server? What's the benefit here? Why complicate it so much? So this has some key benefits. Many databases and tools provide executable server packages, like NPM packages, right? So you could use them to spin up your servers. Think of it like starting a small adapter that speaks MCP and exposes a set of typed tools like list, query, etc. while the server itself talks to the vendor's REST or software development kit under the hood, your app never calls the vendor SDK directly. It talks to the MCP server, which then calls the API. This is super useful for change management because the vendor owns the logic of the server and can absorb any changes that happen to the APIs. So you're not stuck fixing that glue code and figuring out what all the right parameters are, as long as the server logic doesn't change. So as long as the tool contracts, such as the input schemas, the names, the result schemas, etc., don't change, or perhaps evolve via versions, you do not need to change anything about your application. So in short, the MCP layer decouples your app from vendor-specific SDK churn. Okay, so we understand how MCP works at an abstract level. Let's go a little bit deeper into what happens inside. So MCP server is supposed to follow certain rules. And these rules make sense from a large language model point of view. So things become easier with a large language model when the structure for asking a question and getting a response stays the same across different tools. So a MCP server is supposed to follow the JSON RPC 2.0 format for exchange of messages. Now, what is this protocol? So it's a JSON-based wire protocol for remote procedure calls, RPC. This protocol requires the following fields that you're seeing on the screen to be present. Notice that this protocol itself has no authentication. You layer it on the transport to make sure there's authentication. MCP uses JSON RPC 2.0 because it's simple, transport agnostic, and provides a well-defined request response envelope with clean error objects and batching. MCP runs it over STDIO or HTTP transport. The MCP server needs to have the following components in order to qualify as one. It has to have a transport envelope where it follows this protocol we talked about. When a client sends an initialization request with protocol version, client information, and capabilities, it needs to return the protocol version, the server information, and the capabilities. When the client sends the notification without an ID, the server needs to signal that it is ready and the regular operations can start. As you can see in this diagram, the server has tools, resources, and prompts that the client can list and read in order to use them. If the server declares a capability in the initialize result.capabilities, it must implement the matching RPCs. So essentially, tools has to have an implementation of tool listing and calling. Each tool includes name, description, input schema, and some stuff like optional annotations. Similarly, there are resources, and again an implementation of listing them, reading them, etc. exists. Once we have an MCP server, here's how the interaction works. First, there is an initialization where the client opens the session by sending the initialize request with the protocol version, the client information, and the capabilities. This declares that the client understands and starts the version or capability negotiation. And then the server replies with initialize result, which has the protocol version, the server information, and the capabilities. Now both sides agree on protocol version and which features the server exposes, like which tools, which resources, which prompts, etc. The client then sends a one-way I'm ready notification. After this point, the normal operations are allowed. A client can ask what tools exist, and if it does, then the server returns an array of tool objects. so that the LLM or the client knows what can be invoked with what arguments. The client can also ask what resources are available. The server then returns resource descriptions so the client can browse and read data. Similarly, the client can also ask what prompts are defined, and the server will return the prompt definitions, names, arguments for structured prompt retrieval. If the client chooses a tool and executes it with typed arguments that satisfy the tool's input schema, then the server returns a result containing the content. So this clarifies how we have a server and client architecture in MCP, why it makes sense to move all the glue code to the server side, and why the existing REST API is not something that can do this. Now let's go back to our example. Most of us want to build a personal assistant or something that can help us in smoothing out our daily activities at work or outside. You'll find MCP server packages for things like file systems, browser automation, CloudWatch, Datadog, Jira, Slack, Pinecone, Supabase, and more. The pattern is the same. You either spin up your local server or connect to a remote server provided by the vendor. Your app speaks MCP, the server speaks the vendor's API, and you get a typed discoverable surface instead of SDK glue. This does move the logic to the server side, but that's precisely what you want. So given all this information about MCP and how it works, what are the cases where you should not be using it? If you have a one-off simple task, which has exactly one API call, it's a lot of overhead to have an MCP for it. And if you have latency requirements, then direct calls to APIs are much faster compared to using an MCP. If you have very sensitive data with zero tolerance for new surfaces, then you should stick to your existing pipelines, even if they have glue code. And if you have very limited clean bandwidth to run servers, you could manage this by using function calling. If you want an agent that can plug in into many systems today and then have the ability to swap it out later, then MCP is perfect for you. It gives you a stable, inspectable, vendor-neutral interface, with of course known risks and guardrails. Use it where its strengths matter and choose simpler options where they don't. So that's a wrap. Thanks for joining us on AI Club Pro, and hit that subscribe button for more AI insights like these.